Hello everyone, welcome to Sergio Prato's YouTube channel. So in this video, we're gonna talk about how to enable new hardware in the Linux kernel, like from reading the schematics to enabling the drivers and changing the device tree. So the idea here is to show you the process of enabling support to a new hardware in the Linux kernel, so you can access the hardware from user space. Um, to make that simple and focus on the process, I just selected a very simple hardware, an LED. So the idea here is to enable access to the LED. Um, Knowing this process, of course, you can do this with any kind of hardware. There will be hardware more complex, like let's say you want to enable a display or maybe a camera. It might be more complex, of course, than what we're going to do here. But again, understanding the process, it's going to be easier to do this with other pieces of hardware. So before we start the explanation, I just wanted to show you the hardware that we're going to use. So we're going to use a hardware from Toradex. Here I have Colibri IMX6 module from Toradex. And this module is connected to the Aster board, also from Toradex. And I have a small expansion board that I created and I use in my training. And there are several peripherals like LEDs, buttons, sensors, that kind of stuff. So in this video, we're gonna learn how to enable an LED from this platform. Yeah, so let's get started. The first thing that we want to do is to try to understand the configuration of the hardware. Because if you don't know the hardware, how can you configure the kernel to access that hardware? So that's the first thing that we're gonna do. You can see now the board there in the other camera, and there is an LED there. I can show you the schematics from this board. It's open source. It's on my GitHub. If you go to my GitHub/Sergio Prado, you can download this schematic if you want. And there we can search for the LED. That's the LED that we're going to use, this one. Let me increase the size a little bit. So this is the LED that we want to access from user space. Let's try to find out what is the GPIO pin that this LED is connected to. We can see here that it's connected to the signal, LED red, good. And then if we follow the schematics, we're going to see that this signal is here, LED red. As we can see, it's in this connector. So the Aster board has this kind of Arduino connector. So you can connect Arduino shields. And this is a kind of Arduino shield, but I have never tested in Arduino. I have only used it in this platform. But yeah, so we have here the Arduino standard for shields that I used in this board. And now to follow this signal, we have to open the data sheet from the Aster board. So let's do this. I have it here somewhere. Aster board. So this is the datasheet from the Aster board, and let's search for Arduino. Here we go, Arduino headers. So this is the specification for the Arduino headers, And we want to understand here, because in the end, this is connected somehow to the SoC. So we want to understand and know what is the GPIO pin from the SoC that this LED is connected to. So let's get back to the schematics. Here we can see that there are 4 connectors, right? One is for power, and then we have 3 other connectors, one that has 6 pins, the other has 10 pins, and the other 8 pins. So our LED red connected to the 8-pin connector. Then go back here, we can see that this is the 6-pin header, this is the power header, this is the 8-pin header. So this is the one. We can also confirm, because here we can see the UART, TX, and RX signals. And our LED red is here. It's the 30 pin, right? So that means it is this one, the 30 pin. The UART pins are here, and then we have ours here. So this is the pin that the LED is connected to. And this is the pin that we want to follow, right? And we can see here that this pin is connected to the pin number 28 from the SOM, the system module. Now we have to open the datasheet from the system module from Toradex to try to identify what is the GPIO pin that is connected to this signal. So let's do this, 28. Now I have here the system module datasheet. I'm lazy, I'm going to just search for 28. Maybe we can easily find it. I think there is a table, yeah, there is a table here. So this is the table with all of the pins from the SOM system module and where it is connected to in the SoC. So if we look for the 28, it's here. We can see that the 28 pin is in the ball GPIO 09, that the GPIO 1.9, as we can see from here. I'm gonna copy this so I don't forget it's here. So we found that our LED is connected to this GPIO pin. GPIO 1, the first controller. This SoC, I think it has 7 GPIO controllers. This is the first one. And our LED is connected to the pin 9 of this controller. All right, now we know the hardware, right? Now the idea is to enable the LED in the Linux kernel. Before doing that, we might want to just test the LED. Why not? Let's try this. Now I have to connect my board. Just a second. Connect the serial port and the Ethernet. All right. Let me go to the console here. Let me turn it off and on again. So I have my device configured to boot over network because it's easy to work, booting over network. All right, booted. So let's quickly test our LED, right? Since we now know where it is connected to, GPIO 1.9. The user interface for GPIOs, the Linux kernel, there are 2 possible user interfaces. So you can access GPIO from user space via this interface here, sysclass GPIO. This is the old and kind of deprecated interface. And there is this new interface in /dev called GPIO ship. It would work both ways, but I'm gonna use the new interface, GPIO ship here at /dev. And it's very easy to access the GPIO from there, because if you install libgpiod in the device, you're gonna have some tools that you can use to access, read, write, toggle, manage GPIOs. So I have my system built with libgpiod, so I can do this. I can run here GPIO. So I have these GPIO commands. For example, I can run GPIO info and I can see information about all of the controllers. So what you are seeing here is all of the GPIO controllers, right? And we can see here that we have 7 GPIO controllers. The one that we want to use, the first one, and on Linux, it starts with 0, so GPIO ship 0. It's the GPIO 1 that we saw in the datasheet. So that's the one that we want to access. We can ask information about GPIO controller 0 with GPIO info 0. So we want to access this one. We can confirm here, right, the same number that we saw in the datasheet 28, right? So that's the one that we want to access. And then we can just use GPIO set, then the controller, then the pin equals 0 or 1. So I'm gonna turn the LED on. As you can see from the board, it's on. I can turn it off, and we can confirm that the LED is working. But the Linux kernel has an abstraction for LEDs, and our idea here is to enable this abstraction. So we want to have access to this LED via an interface in sys-class LEDs that I don't have it yet because it's not enabled in my kernel. So our idea here now is to enable this interface and also define a node in the device tree, so we can see this LED here and we can access this LED using this interface. And then I'm going to show you how useful this interface is for managing LEDs. It's much better than just toggling the GPIO. So let's do this. And that's one of the important things about this video. So you need to understand this process. Every time you want to enable a hard device in the Linux kernel, you have to do 2 things. You have to enable the corresponding drivers, and you have to possibly add an entry in the device tree. Why possibly? Because there are some devices that enumerate themselves. For example, you don't have to describe a device in the device tree if it's an USB device, for example. Only devices that are not able to describe themselves at boot time or at runtime, you have to do it in the device tree. All right, so let's do this. Let's start with the kernel. So I have here the Linux kernel. It's just pull it, the latest version. Let me check here what I'm running right now. Proc version. So I'm running 6.8 RC7. It's a mainline kernel. I'm just building from Linux repository. All right, and that's what I have here. And yeah, let's configure the Linux kernel and enable support to LEDs. So device drivers, and then we're gonna search for LEDs support. Here we go, LED support. We want to enable this to have access to LEDs. We can go to the menu, and then we need to enable LED class support. I'm gonna enable everything as built-in. And now we have the LED drivers. So this LED class support just enables support for LEDs, for the framework, not for the drivers. You also need to enable support for the drivers. As you can see here, we have several controller drivers for LEDs. But our LED is like very simple. There is no controller. We just want to associate the GPIO with the LED. So there is a driver for that. This one, LED support for GPIO connected LED, because our LED is connected to GPIO. That's what we want to enable. Another thing that we might want to enable or check if it is already enabled, it's the triggers. So LED trigger support is a very nice feature from the LED framework, where you can enable an event that would toggle the LED. For example, with this trigger, you could enable the LED to turn it on when you write to the disk, or when you have traffic in the network interface, for example. It's a very nice feature from the framework. Let's enable everything that we can here, all of the triggers, so you can play with them. We're not going to use all of these, but anyway, let's enable everything. All right, now we have the support enabled in the kernel. Let's debut the kernel image. So here we go. It should be fast because my kernel was already built, and the kernel, the build of the kernel is incremental. So we will just build the things that I changed. As you can see, done. Since I'm booting from the network, now to test this, I can just update the kernel image in my FTP server and then reboot the device to boot the new kernel. Let's wait a few seconds. All right, now we have the LED support enabled in the Linux kernel. We might want to check if there is any messages in the kernel logs, right? You can see messages about the trigger. We can check if this interface is available, sys-class LEDs. It is. Nice. Now it's time to enable our LED. So the second part of this process, now that we have the driver enabled, it's time to define the device, declare the device in the device tree. So the kernel will know about the device and it will instantiate the driver, probe the driver that will talk to the device. So that's the second part. That means you need to know what is the device tree that you want to, that you are using in your development platform, and you're gonna have to change it. Now, what do we need to do in the device tree? I mean, how do we know that? We want to enable a driver, we want to enable a device, the driver is already enabled, we want to enable a device tree. You're gonna probably, if you don't have an example on how to do that, sometimes your vendor, I don't know, provide you some kind of example on a node that you need to add to the device tree. But in general, what you need to do is to look at the device tree bindings. So in the Linux kernel, you have this directory, documentation, device tree bindings. That's where the device tree bindings are stored. That's basically the device tree documentation, right? And we can just search for our device there. That's basically LEDs, right? So that is a directory. You can do greps, of course, if you want, but it's kind of easy to look for things, the device tree bindings directory. So you have the LEDs directory, and there you have bindings documentation for the LED's drivers. So our driver is the LED's GPIO driver, and this is the binding for this driver. I'm gonna open it here. What is a bind? It's a documentation on what you need to add to the device tree to work with that driver, right? Because the device tree has two main objectives. One, to declare the device to the Linux kernel. You want to say, kernel, that is an accelerometer connected to the I2C bus. And the second thing that you want to do is to pass to the driver information about this device. So you want to say, dear device driver, this accelerometer is connected to bus I2C2 and it has the address 10. So that's the idea. It will instantiate the driver to talk to the device and also pass information to the driver. And in the past, we used like txt files for defining the binding, and that was not very good because it was not standardized. And then a few years ago, it was decided to use YAML files, as you can see from here. And this is the specification where they say about what are the properties that you want to use in that device tree, description about the properties, and so on. What is nice is that in the end, you have examples on defining this node in the device tree. You can just follow an example, as easy as that, or copy and paste the example and change to your own needs. That's what we're gonna do here. So we're gonna take this example. Now I'm gonna open my device tree. That's not this one. I have it here, this one. This is the device tree that I'm using to boot. And I'm gonna add it here. So since it's an LED that is not connected to any kind of bus, I can just add the node to the main node of the device tree. As you can see here as well, there are two include files. This is basically so we can use macros in the device tree. Like this one, LED function is a macro, right? There is also the LED color macro. All right, so let me clean up this a little bit so I can explain you how this works. I don't want a default trigger. I want the function status, and also I want to set up a color. I think the example we have, let me copy and paste, that's easier. Let me also indent with tabs, because device trees are indented with tabs. So it will look beautiful. Our LED is red. Let me change here. All right. Now looks good. So we have here an LEDs node for our LEDs. In this case, that is just one LED, but I could add more nodes for more LEDs. Then we have this compatible property that defines the driver that will handle this node. So in this example is the driver registered with this compatible. If you want to look at the driver, I can show that for you. So the driver is here, drivers, LEDs, GPIO. Let's see, this is the driver. And then if you search for compatible, you're gonna see that the compatible of this driver is GPIO LEDs. So that's how you bind the device tree node with the driver using this compatible property. And this is my first LED, first and only LED. This property defines the GPIO that the LED is connected to. So we have seen that it is connected to GPIO 1.9, sorry, 9. So this is a handle pointer to the GPIO 1 controller. If you look at the device tree include files, you're gonna find the node for this controller. I can quickly show you. It's in another device tree. I think it's this one maybe. Yeah. So this device tree is an include device tree that has the main configuration for the SoC family IMX 6 quad dual and light from NXP. So it's a kind of base device tree for all platform devices that use this family of SoC. And here we can search for GPIO, and we can see here the controllers, GPIO 1 from 7, and they are here. So this is the node for the GPIO 1 controller. Now, in our device tree, we can just point to the controller. That's kind of easy, right? GPIO 1, pin 9. And then we need to set if it's active low or high. If we look at the schematics, we can see that we are using an NPN transistor. That means we need a high signal here to have current here. So it's active high actually. So we need to change here. So it's active high. I'm saying that the status, the function is status, could be anything, and the color is red because the LED is red. I guess that's it, right? So let's save this. Then let's build a device tree. Let's copy to the FTP server. And now let's reboot the device. So it will use this new device tree and see if it works. You can check if the node that you added to the device tree is there by listing proc device tree. So here we have a representation of the device tree in the file system. We can see here that we have the LEDs node that I added, right? And we have the LED 0 node inside of it. And then we have there the name. That's just LED 0. It's all there. Now we can check if we have the interface in C-class LEDs. And we have. So now we have an LED called red status. That's what I used, right? The color and the function. Red status in C-class LEDs. I can go there to access this LED. So now we can see the interface for LEDs in the Linux kernel. This is the interface. You have 3 important files here. You have the max brightness that will tell you the maximum brightness of this LED. Because it is an LED connected to a GPIO pin, there is no kind of way for you to change the brightness of the LED. So that's why the max brightness is 1. But of course, for example, if you have an LED connected to a PWM channel, right? You can change the duty cycle of the channel, and that means you can change the brightness of the LED in the end. But that's not possible in our hardware configuration. And having 1 in max brightness, that means that I can write from 0 to 1 in this brightness file. So if I write 0, the LED will be turned off. If I write 1, it will be turned on, as you can see in the board, right? 0 and 1. In the end, it's just an abstraction, right? Because we can do the same thing accessing directly the GPIO. This is just an abstraction on top of the GPIO interface. And one thing that is nice about this is that you have this trigger feature. So you can enable, you can see here all the triggers that I enabled here, right, during the kernel configuration. And you can enable any of those features, any of those triggers. For example, you want to blink the LED, there is a trigger called timer. So if you write timer to the trigger file, then you're going to see the LED blinking. This trigger will create 2 files here, delay on, delay off. So you can define the frequency of the blink if you want. It's 1 second by default. There is another nice trigger called heartbeat. I will enable it. It looks like the same thing, right? The LED will blink, but actually this trigger is about blinking the LED in a way that the frequency of the blink will change depending on the CPU load. So let me show you. I'm going to increase the CPU load. I'm going to just run something here. Do true, done. So let's burn the CPU. Now look at the LED. You're going to see that the frequency will increase, like the heartbeat will increase. And since it measures the load over time, I don't remember if it's 1 minute or 5 minutes, but it measures over time. I think it's 1 minute. That means the frequency will increase over time. Just like our heart, right? It increases over time. As you can see now, it's blinking very fast. That's very nice. I'm gonna queue. And the same thing will happen when I kill everything. Now, like, the system is basically idle. So the frequency will decrease over time. That's a very nice indication, right? To have a product, if you want to use this feature, that's a very nice indication on the CPU load, a visual indication of the CPU load. That's very interesting. The last trigger that I want to show you is the disk trigger. So you can see here that there is this MMC0 trigger. If I enable it, then now every write to the eMMC interface will turn on the LED. Let me show you here. I have a dd command here. So I want to write 0 to the eMMC device. That's the eMMC device from the SOM. I'm not going to use it, so that's why I'm just writing zeros there. And so I'm writing 10 megabytes. You can see every write turns on the LED. So it's a nice visual indication of access, writing access to a storage device. Very nice as well. All right. So that's what I have for today. I hope you enjoy it. So again, maybe I could do another video with a more complex device, maybe a display, camera, or something else, sensor. But the important thing here was the process, right? Every time you want to enable access to a device on Linux, you're going to have to find out first the configuration of the hardware. Second, what are the drivers in the kernel? Third, what kind of changes you need to do in the device tree. That's kind of basically the process. And it's usually, every time it's a different experience, right? You have a different devices, connect to different buses, different drivers with different interfaces. And that's why we are always learning when we are working with Linux. And for me, at least, it is very nice. Okay, so I hope you enjoyed this video. Leave some links in the description of the video about everything that we learned here. If you enjoy the contents, don't forget to click in the link, but in the like button, subscribe to the channel, share with your friends. Feel free to leave a comment in the description of the video as well. If you want me to cover any kind of topic, just leave a comment there. I plan to release one video per week. Yeah. And if I'm out of ideas, yeah, your comments will be very useful for me. So I hope you enjoy it. Have fun playing with embedded Linux, and until next time.